Okay, on today's lesson we're going to look at special right triangles. Those special right triangles are a 30, 60, 90 right triangle and a 45, 45, 90. And what makes them special is the relationship between the angle measurements and the ratio of the side lengths that they always have. And here you can look down here at the bottom, we've got a 30, 60, 90 right triangle, and the ratio of 1 to the square root of 3 to 2. And on a 45, 45, 90, we've got 45, 45, 90, and a 1, 1, and the square root of 2. The key to working with these special right triangles is memorizing these ratios and knowing which one works with 30, 60, 90, which one works for 45, 45, 90. The great thing about this is it is on our formula sheet, and it gives you 30, 60, 90 and the ratio 1, square root of 3, and 2, and 45, 45, 90, 1, 1, square root of 2. So let's look at an example here. What type of triangle do we have? We've got a 30, 60, 90 right triangle. That falls within one of our special right triangles. And so here's an easy way to figure out all the side lengths given just one side length of the 30, 60, 90 right triangle. We write out what type of triangle we have, 30, 60, 90. And then below it, we're going to do this kind of like an Excel sheet to where we have columns. Okay, we're going to do straight lines down, straight lines across. We've got to remember what the ratio of a 30, 60, 90 triangle was. And the ratio was 1, square root of 3, and 2. So that's our ratio. Now, on our last column down here, what we want to do is we want to write out the side length that we know. Now, how do you determine where 4 is going to fit within our column chart over here that we have? You're going to look at it, and it's going to be the angle opposite the side length. That angle opposite the side length is 30. So 4 is going to fit under our 30-degree angle in our chart over here that we have. So now all we do is we do exactly what the ratio says. Our ratio of 1 was 4. So let's look at our 90-degree ratio, which is 2. Very simply done. 4 times 2 is 8. So our side length across from our 90-degree angle is 8. Now, our 60-degree angle is the square root of 3. That's the ratio. And what that's saying is it's 1 times the square root of 3. So in this case, we want to do 4 times the square root of 3. And you can leave it in that form, or you can work it out and calculate it out. And if we did calculate it out, we get approximately 6.928. So you can leave it either way. The 4 times the square root of 3 is a more exact answer. 6.928 is rounding a little bit. But you can see, if you can set up your chart, it becomes very simple to do. So let's look at this next one here, this last one. It's a 45, 45, 90 triangle. So again, we kind of want to write out our chart. Now we've got to remember what that ratio of a 45, 45, 90 triangle. And if we remember, when we talked about isosceles triangles, if the angles are congruent, what did we know about our side lengths? They are also congruent. So our ratio, 1, 1, and the square root of 2. And I always remember the square root of 2 is because I have two side lengths that are the same. So the ratio is going to be the square root of 2. So we plug in what we know, our side length. It's across from a 45-degree angle. So that's going to be 10. Well, obviously, if we have an isosceles triangle, which with two angles being the same we do, this one is also 10. And then what do we do with this 90-degree angle? 10 times the square root of 2. And again, you can leave it in that form, or you can multiply it out. And get approximately 14.142. So you've got 10 on this side length because it's across from a 45-degree angle. Across from our 90-degree angle, we've got 10 times the square root of 2, or approximately 14.142. So that's the way to use our ratios on the special right triangle. We'll talk more about and do lots more examples in class. Thanks.